Thank you. Thank you very much for the kind introductions. I'm very happy to be here. I know I prefer to be here in person, but hey, it is what it is. So let's get started with this presentation. I'm kind of monitoring the chat at the same time. I have it on my screen right there. So if you have any questions, feel free to ask away. I'll either stop or whatever, mention that I'm going to talk about it later if it's covered later. So what I want to talk about today is Kubernetes. And um, but just before I get into that, let me tell you something about myself. I love good food. I'm a bit of a foodie. I love good food. I love food TV shows like all the time. Uh, and when I first started playing with Kubernetes, uh, it was just like so complex, and I was like, oh bloody hell, what is going on? And I couldn't understand anything that was happening, and I it was just like overwhelming. I mean, I have been a developer for many years now, and I can pick up a language. I've been able to jump into different projects. um, and I thought that trying to learn DevOps would be an easy thing, but it turns out that it wasn't. So I was really like bloody hell, and that made me thought of Gordon Ramsay, and I've been looking for an excuse to do a talk which was related to food for quite a while now, but I don't have the rights to his picture, so I removed the Hell's Kitchen and removed the pictures of him. So, so let's not talk about that. But yeah, so like I said, when I joined Red Hat, that was about a year and a half ago now, and I joined this team where we work on the Kubernetes platform that we have called OpenShift. And really, I thought it would be easy to understand, but I had never used a container. I had never mind Kubernetes. So the learning curve was really, really steep for me. So what I wanted to do here today is to, first of all, I'm going to just do a small parenthesis to say, if you're just kind of like me and you don't know what containers and Kubernetes are, I'm giving a workshop. This Edgar's will post the details anyways in just a few seconds, I guess, if he's still around and paying attention. But next week, Thursday, Wednesday, Thursday, I should definitely be aware of it. But sometime next week, if you're interested, feel free to join us. But yeah, so I didn't know any of that, and I thought it would be easy, but there was a lot of things to learn. So my goal here today is to kind of give you the basics of what Kubernetes is, so that at least you have a starting point, so that next time that if you need to start playing with Kubernetes, at least you'll have the right terms to start Googling. You'll have the necessary information, and you'll kind of know what to Google. They have a great documentation. So Kubernetes.io is the website. A lot of good stuff there, but it is a little bit dry. So I'm going to actually give you some definitions from the website today. You'll see like it's a bit dry. So that's why I'm going to give you a little bit more context around that. All right, so what does Kubernetes solve exactly? What does it do? Well, it distributes all of your containers in a logical and efficient way. So maybe you've worked with containers already. You've used Docker Compose and things like that. Well, Kubernetes will really take care of distributing all the containers across a big array of machines in a way that will make sure it's always up and running. It helps you to scale up and down really, really fast. So if you need to, add more containers, it's just a CLI command line that you type in, and boom, you have more containers serving your customers. And also, it takes care of all the making sure that all the processes are continuously working. So if you need to take down or if you need to upgrade one of your microservices, it will make sure that it will spin up that new service or that new container and continue to deliver the traffic at the same place. And then once that first container is up and running, it will destroy the original one, so that you always have your processes continuously working. So that's kind of what it does. And all of that is done using YAML files. So there's going to be a lot of YAML today. So sorry about that. But, it's not that bad. So take my money, right? It solves all the problems in the world, and everybody wants to use Kubernetes now. Or is that the case? Maybe not. Maybe you don't need Kubernetes, actually. And just before I like to just take a moment and say, it is it's a great tool. It's an open source tool that is available, but it doesn't solve all the problems in the world. maybe your application is a little bit like this here. Maybe it's, maybe you don't have millions of users, but you got to make sure they're served in a timely fashion, and maybe you've joined a Jamstack movement, and you have kind of a static website, like a Gatsby website that can do some really powerful stuff nowadays. Or maybe you have a WordPress or a Laravel application, which are great for a lot of purposes. So maybe the food truck model is a little bit better suited for you. Maybe you want to just have like just an application that is hosted on Netlify, which will be free virtually for smaller applications, or GitHub Pages. Just turn your repo into a website. I have a lot of repos and workshops that are actually that are served that way. So any virtual host will be able to do all of that for you. It will handle a good amount of requests if you can put static files there. So maybe that's all you need for now. So maybe you don't need to jump into the Kubernetes wagon yet. Or maybe what you have is not a food truck, but maybe it's more like a pizzeria, maybe a small shop, but a relatively simple workflow. One person at the cashier, and then another one in the kitchen. Kind of a startup, and you have a front end and a back end, basically. So you've got two containers running, not too many customers, but it's a good time to start with best practices at this point. So using containers to deploy your application is definitely a step in the good direction at this point. But you can still use something like Heroku just to handle those containers, as long as you don't need to start scaling up and managing all the networking between all those containers. Probably that's a good solution for you at this point. But definitely that's a step in the right direction if you want to eventually make your application larger and scale it to a larger scale. Then starting to use containers makes sense. Maybe you have something more like a buffet, a little bit like this. Everything is right there for your customers to use, and when they're ready, they open it up and they take whatever food that they need and then close the lid there. Can you guess what that is? What type of architecture that is? Hint, there was talk about that earlier today. So serverless, it's kind of a serverless architecture here, right? A buffet, people just come in, take whatever they need and close the lid. So in that case, you're way better off using Lambda functions or Azure functions or Lambda, AWS Lambdas or Azure functions. I always get them mixed up. So those are very well suited for a lot of use cases. You just had a presentation, so I won't go through the details of that. But maybe what you have is something more like this. It's kind of an upscale restaurant. It's a fancy place here. So in this case, you have multiple staff members working together to bring this amazing meal to the people. And just here's another fun fact. That waiter to the complete left, I guess, of your screen, that's actually me. So I used to work in a fancy place like this. So those places, you need the input of many different many cooks, many waiters, a lot of staff is involved, and there can be no point of failure in that chain. And most importantly, you have to make sure everybody's at the right place at the right time, right? It's very important, and you have those very well defined lines of communication. Not every waiter is allowed to just go in the kitchen and talk to the chef, or one of the cooks. There are some established lines of communications that are very important. And if you have something like that in your software architecture, well, that's when you need Kubernetes, right? You can't have any container talk to each other. You kind of need to organize this a little bit more. You got to make sure they're all up and running, and so on. So what does Kubernetes does? What does it do for you? Well, deploy more or less containers. That's essentially all that it does. It distributes the load across those containers. So you can expose a bunch of different containers, and it will take care of doing all that load balancing for you, all that stuff. It really takes care of all the networking between all of your containers. So that's one of the big aspects that it does. And when you start deploying larger architecture, you can see how that can get really messy real quick. All right, so what we're going to do today is that I'm going to show you a few demos. We're going to deploy an application, and of course, this application will be a restaurant, right? We'll serve some food, so that will be. But just before we get to our grand opening, let me just introduce myself quickly. So, hi, my name is Joel. I'm based in Ottawa, Canada, where it's freezing right now. But I guess it can't be that hot in Latvia either, from what I recall from my last trip over there. I work as a developer advocate for the Red Hat OpenShift platform, which I've already mentioned is the Kubernetes distribution from Red Hat. So feel free to take a look at that. And if you ever want to get in touch with me, Twitter is always the best way. I'm always available on Twitter, Joel with 2 underscores Lord. So Joel _ Lord. It's kind of a weird Twitter handle, but yeah, it is what it is. And whenever I get a Twitter notification, I get really excited. So, you want that. Of course, I also post gifs of myself, which you don't want to miss. Okay, so let's get back to our restaurant, to our grand opening. And what we will serve here is poutine, because I'm French Canadian, and that is our typical meal. So typically poutine is fries with gravy and cheese. Which doesn't sound very good, but there are some very, very good versions of it. Like this one is a duck confit poutine, which is served at a restaurant nearby here, and it's absolutely amazing. So, let's get back to our topic at hand, and let's open up our restaurant. So the first thing that we'll need is some space, right? We'll want to have a space. We'll also need stuff like electricity and gas to fire up the ovens, maybe even a kitchen. And of course, ideally, we want to rent out a space, because we don't want to. I mean, we could build our own, which is nothing wrong with that. But if you want to, start somewhere, it might be a good thing to just rent out a space in downtown, so you don't have to tear down buildings and start something new. And of course, when we rent out this space, we will sign an agreement with the owners, and the owner will guarantee, that we will have like gas and electricity and all those resources, and the owner will take care of fixing any issues that might happen as well. So that's a good thing. So that's kind of like our Kubernetes cluster, right? A Kubernetes cluster is a set of machines called nodes that run containerized applications managed by Kubernetes. A cluster has at least one worker node and at least one master node. Now, I still kept worker node and master node in this slide, but they are slowly changing the terminology for primary node and something else. Anyways, but if you see a master worker or primary / something else worker, I think, you'll know what it is. So most major providers have those available for you. I mean, Azure, Google, AWS, they all have their own distribution of Kubernetes. IBM Cloud has a 30 days free cluster for 30 days if you want to give that a try. And of course, Red Hat OpenShift has one as well, 14 days where you can really test it out. So there's a lot of cool stuff that you can try out there. So try with someone else's cluster for starters. Now, worker nodes, what is a node exactly? Well, a node is basically just a machine. It could be a physical one or a virtual one. And worker nodes are where all of our pods or containers will be hosted. In this case, in the case of the demos that I'm going to show, I'm going to run a Minikube cluster, which is a Kubernetes cluster that runs on your machine, and it has a single worker node. Typically, you'll have like 3 different nodes so that you have some redundancy, but all of our pods are going to run in there. Now, you also have master nodes, and the master nodes are in charge of managing the worker nodes. So basically, they decide where to distribute all the containers, and they kind of manage the overall architecture, the overall infrastructure instead, not the architecture. Typically, you would have more than one master node as well, just for redundancy purposes. But when you get some of those free clusters, such as the one on IBM Cloud or Minikube, then you only have one. All right, if you want to start your cluster, if you want to use Minikube, like I said, that's definitely my favorite way to test it out on a local machine. Minikube Start is the way to get started. I will share one link at the end with all the different links that I shared today, so you don't have to take them in note as we go. All right, so that will take a few minutes, and we'll start a Minikube or a Kubernetes server. And next, we'll need a staff. So we'll need a bunch of different people for our restaurant, right? And all of those people will have specific expertise, and those are the little applications that we're going to deploy today, and different components of our Kubernetes cluster. So let's get in there and let's get started with our first component that I'm going to introduce today. I'm going to talk about pods. Pods are the smallest unit available in Kubernetes. So a pod will contain one or sometimes more containers. But if you have more than one, you have to make sure that they're really, really tightly connected. You have to make sure that if one dies, they're all gonna die, right? Because a pod will be spun up or down all together all at once. So if you have if you have a backend and a database, for example, make sure that those are in two separate pods. So if one goes down, the other doesn't. But if you have things, maybe you have like a MySQL database and a PHP admin, those two containers can kind of go into the same pod because one is useless without the other. Pods are co-located on the nodes and they are identified by labels. So you'll see today everything in Kubernetes work with labels. You can identify and find the different objects in your Kubernetes cluster by using labels. All right, so the first thing that we'll want, is to have our maitre d'. If you've ever been to a restaurant, you might have seen that maitre d'. And if you've worked to a restaurant, you know that you can't just let the waiters work whenever they want, right? Some of them would be too greedy and they would work too much, and others would only come in on Fridays and Saturdays where they make some money. And if you have too many of them, well, it's going to cost you too much money. And if you don't have enough of them, then your customers will suffer. So there's this balance, and to do that, you need a maitre d'. She's in charge of making all the schedules and all that stuff. And in our system here, she'll represent the deployments, maitre d' deployment. All right. So in deployment, what it is from the Kubernetes website, once again, an API object that manages a replicated application. Each replica is represented by a pod, and the pods are distributed amongst the nodes of a cluster. So what does that mean, really? The deployment is kind of the plan for our pods. How many pods do we want, and when do we want them? And that's what a deployment is. It really describes what it is that we want. Once you create a deployment inside your system, it, in turn, create a replica set, and the replica set is in charge of making sure that there's always the number of configured pods running inside your cluster. What does that look like? Well, like I said, we're going to use some YAML to describe that. And our first, YAML files in Kubernetes always follow the same pattern. So we've got an API version, which identifies what type of object this is. You've got the kind of object. So in this case, we're going to create a deployment. You've got some metadata in there. You'll specify the name and the labels for the object. And then you have the spec where, pretty much everything goes. So for a deployment, we can use the API version apps./v1. We're creating an object of kind deployment. We have some metadata. So in there, I'll put in a name, so front deployment, and then you have labels. Labels can be just whatever key value pair that you want. So in this case, I'm going to say, well, it's part of the Kube Kitchen application, and it has a job of maitre d', and the section is front of the kitchen. In the spec for my deployment, I'm going to specify first the replicas. So how many pods do I want running at any given point? And then I'm going to specify a selector. So the selector is, in this case, it uses matched labels. So it will look for pods that have the label job equals waiter. And next, we specify the template for the pods that are going to be running. So in this case, I'm creating a few pods, which will have the following metadata. So that's the metadata and the labels associated with the pods. And then the spec for my pod contains an array of containers. And in this case, there's only one container, which will use the image joelor/kk front, which is just a PHP application that serves files. So this is kind of what it looks like for a deployment. So if I go in here, and let me just, there you go. That should be a little bit better. And I'm going to use kubectl, which is the tool to interact with our Kubernetes cluster. And I'm going to say apply. And now I need to remember the exact front deployment. OK, that's what it is. So that created my front deployment. And now I can do kubectl get all. And you can see that I have a bunch of stuff coming up. And those are container creating. So they're slowly coming up. And they will be deployed in just a few seconds. So you can see here that I have my deployment, the one that I've specified and created, which has 0 out of 3 pods ready. It also created a replica set. The replica set is making sure that there's always that desired count of 3. And then I've got my pods, which were all assigned a random name based on the name of the deployment, the random ID of the replica set here, and then a random identifier for that pod. Let's try to get all again. We should see they're all up and running now. So we've got desired 3, 3 out of 3 ready. So we're good to go. We've got those 3 deployments. Now say that I'm expecting a sudden burst of traffic and I need to scale up. Like I know I'm gonna have a bunch of people, it's Friday, 5 o'clock, and we need to have more people on the floor. So kubectl scale dash replicas, and I'm gonna say I want 10 replicas of the deployment front deployment. And I think that's the syntax, that's correct. So kubectl get all, and now you can see that I have all those pods and they're all running. So I'm ready for that sudden burst of traffic. They're slowly getting all created. And now my traffic eventually will be distributed across those pods. Let's scale back to two. We only need two, maybe three, just in case. All right, why not? Right, and if I do get pods again, well, you can see that now some of the pods are being terminated. There's still 2 or 3 running. One is creating because I went down to 2 and then I came back to 3, so that one is created. All right, so we can now easily scale up our application. That's all good. That's all good. And this is kind of what we have right now. So you can see that, ignore the fridge for now. So that's a little bug, which I've just noticed. But I've got all of my 3 pods. So those are actually connected to the Kubernetes API. I can actually ping that API myself. The kubectl tool, that's what it does in the background. So I've got my 3 pods up and running with their random names, but there's no way to access them yet, right? So our maitre d' decided that she needed three servers or 3 pods on the floor, but there's no way to find them. You don't know who's there, who's, if it's John or Simone or who's working tonight, and you don't know where they are. Like one is cleaning up a table, the other one is looking at a glass, and the other one is, I don't know, watering plants. So you need to have a way to be able to find those different waiters or just different pods inside of your cluster. And this is where services will help you. So a service is an abstract way to expose an application running on a set of pods as a network service. So what that means is that a service is a way to find your pods in your cluster. You can communicate directly with pods if you want, but because they have a random name, it's kind of hard to keep track, right? And when I scaled up and down, you saw that the names changed. So, there's no way for me to know which one is going to stay or not. So the services are there to really do all that load balancing. So I can ping my service, and my service will be in charge of redirecting my my queries to the matching pods or to the pods that it knows are there, and it will take care of all that load balancing for you. To create a service, same type of thing, API version /app/v1 kind service. We put in some metadata once again, and then we have our selectors. So in this case, I'm going to say this service is for all pods that have the job waiter label, and just map to port 80. So any incoming requests, send that to the port 80 of that of those pods. So this is kind of what a full service looks like. So let's go ahead and deploy that service. Apply -f. Where is it? Front service. There you go. And now if I do kubectl get all, I should be able to. I put an alias for K because I keep doing typos here. So you can see that the service is created here and it maps to port 80s for those matching labels. All right. So our maitre d' now knows where his waiting staff is. That's good. But as a customer, you need a way to talk to your waiters too, right? You won't go into the kitchen and order your own food. The waiter is kind of your door to the system. It's the front end, right? So you'll need a way to expose that service to the outside world, and we're going to use an Ingress to do that. So an Ingress is an API object that manages external access to the services in a cluster, typically HTTP. Ingress can provide load balancing, SSL termination, name-based virtual hosting. So basically, it's a way to expose your cluster, and it can support multiple subpath, or it'll take care of doing all the routing. So typically, if you have an application, you would have www.myapplication.com for your application, but then you would also have api.myapplication.com. So the Ingress will be in charge of doing all that routing based on the incoming requests. Ingresses, they look a little bit like this, extension /v1 beta 1. That is not exactly accurate. They actually moved from a beta to an official version now. I'm creating an object of kind Ingress here. I'm using the following metadata, and I specify the backend. So the backend is where do I want to redirect the traffic? And I'm going to say, well, redirect all the traffic to the service called front service on the port 80. So this is what my Ingress look like. I can go ahead and I will actually need to do Minikube add-ons enable Ingress. because I have an older version of Minikube, but it should be built in now. And then I will deploy this, this actual Ingress. There it is. Timing is perfect. So apply. And we have the Ingress here. And it deprecated, but it still works. So all good. Okay, so what do I have now? Well, now I have this architecture. I've got my front end, I've got my wares, and it's all exposed through my Ingress on port 80. So that's good. I think I'm going to need to enable this if I want to give the next demo. So let's give that a try. So this is my application. And I'm not sure if it's going to work. Oh, maybe not. Maybe not. Let's not despair. Connection refused to connect. Oh, I know why. I know why. Just give me 1 second. I want that demo to work. Come on. Let's validate the IP address of Minikube. IP, not up, IP. 49.2. And there it is. All right. So we've got our pods up and running. So that's our first pod. It's our ware that comes and greet us. And you can see here that it's a GHQ9W that hosts or greeted me. So if I refresh this frame, I can see that it's distributed to another pod. So I have all of that load balancing that is up and ready. Now, of course, I can't order drinks or order anything because I don't have anything in my system. So why don't I just go ahead and talk a little bit about different services. In this case, we're going to talk about our bartenders. Bartenders are usually the ones that will serve you drinks, and they're notoriously known for not being reliable. So we'll try to deploy those, and then we'll try to see if we can fire them or just destroy those pods. So this is what it looks like. The deployment is pretty much the same. And we're going to expose those through a node port. So a node port is a way to expose the service on each node's IP IP at a static port. So cluster IP service, which is node port service route, is automatically created. So basically, it's part of the service. It works well when you have a single node, but it breaks when you have multiple nodes. Not recommended to use usually, but it's good for development practices. And providers have different ways to create routes, and sometimes it can get tricky. So if you just want to test something, then a node port can be useful at times. But really, that's for production stuff. This is what the actual service will look like. So we have a type node port, and then we specify which port to expose to the outside world. So let's go ahead and do a key apply -f. I think it's in the bar, and then we'll apply. Let's just apply everything, and boom. All right, so both my service and deployments are created. So what do I have now? Well, I've got here, as you can see, my two bartenders who are slowly being deployed. Let's go ahead and just do a get all, and they're still creating. I might come back just later just to show. Well, let's just give that a try. I think they're running. Okay, perfect. So we've got all of our containers running. You can also do get all with labels, which makes it a little bit easier. So I can specify job equals barman, I think is how I call it. Yeah, there it is. So now I only have those that have that matching label. So instead of using get all, I've added a label here. So let's take this pod and copy this. And let me just clear this. And I'll do a kubectl delete pod and bar deployment. And now this should destroy my pod. Let's take a look at our architecture to see what this looks like. Well, you can see that as soon as I asked it to destroy this pod, it started a new one so that it would replace the other one eventually. And in just a few seconds, we should, in theory, see one of those bartenders disappear. All right, so now I have my application. I can now order drinks, as you can see here, and I can see who served those drinks. So I'm getting there. I just still need a kitchen. All right. So now the next thing that I want is my kitchen. I want to have my cooks. A lot of people tend to see a kitchen as more of a, oops, you see my slide notes now. You can kind of see a kitchen as a chef preparing their food, but there's a huge team there, and everybody's has to do different things at different stations and so on. So we're going to try to mimic that. inside of our application now by deploying another service. This will be a Node.js service that runs. Here's another cool thing about Kubernetes, that all of your microservices, they don't need to run in the same language. The first one was PHP, this one is Node.js. It really doesn't matter. So I've got all those cooks. I'm going to deploy 2 of them. My service will work pretty much in the same way as I did earlier. So let's do a apply, and then kitchen chef / everything. All right. So that should give me all of what I need. And we can see here, oh, I didn't want to deploy the chef. I wanted to deploy the cooks. That kind of ruined one of my punch. But that's fine. Kitchen / cook. All right, there it is. All right, so now you can see in our architecture, we've got our cooks, but there's this mention here that it's internal only right here. And in theory, you shouldn't see the chef, so just ignore him for now. So how do we expose those cooks? We don't want our waiters to talk directly to those cooks. Maybe that's a service that is talking to the database, and we don't want necessarily our front end to access that directly. So you might need to have something between those. So this brings us to our chef. There's only, usually normally one, and he takes the orders and processes them and gives the orders to the rest of the cooks to proceed with the order. And he's also the gatekeeper to the kitchen. You never want your waiters to talk to the cooks, or else it's going to be a mess. You want that single point of communication, and that is what we're trying to reproduce here. So this is what it looks like, my deployment, which I've already deployed. And now what I have is this architecture where my front end can talk to the chef through the pass, and then the chef will talk to the cooks through an internal channel, so nobody's able to access those cooks from the outside world. So now I can go ahead and order my things, of course, assuming that my stuff is working, which clearly it isn't at this moment. But let's ignore that for now. Just assume that it actually worked. Not sure what happened, but too bad. So what I can do in here is that I can actually access those services through environment variables. So as soon as I deploy a new service inside of my system, all of my pods will actually have the name of those services as environment variables. So you can see here that I can figure out what is the URL for the cooks just by using, and that's why, because I've deployed my chef before my cooks, so it doesn't have those values inside the pod. So if I do get pods -l job equals chef. There we go. So let's go ahead and destroy this one. Okay, delete pod. And this one will be deleted eventually, and it will start a new one, and that new pod will actually have those values inside of it. So there we go. So I fixed it. So, all right, so you can see here that all the requests are sent to all the internal microservices, and they're responded by different people at different times. So you've got all of this up and running. Cool. So those are my environment variables. I'm getting more and more stuff deployed in my application right now. And the last thing that I wanted to talk about is, of course, we can't talk about restaurants without talking about desserts, right? And if you go to a restaurant and if you order, a cake or delicious chocolate truffles, the pastry chef won't just go and start making them. The pastry chef has been making those all day long, and then they're almost ready. So he just puts the final little touch, that little flour on top of it, and serves it. So you can also have different services like that runs in your Kubernetes cluster. Containers don't need to run servers. They can actually be CLI tools or daemons, or in this case, it's a cron job that just runs regularly every minute or so. And every minute, it just adds a new file into my file system. So this is an object of type cron job. I can give it some metadata as well. And I specify a schedule using the Linux architecture. So once every minute. And this is the container that will run once every minute. And next, the other thing that we need, of course, well, we need someplace to store that. So there's that file that is being created every minute, but where does that file go? Well, it goes into a fridge, which is then shared between different people. So persistent volume claims is a way to claim a disk space on your Kubernetes cluster. So whenever a pod is terminated, everything is destroyed. To persist the data, you'll need to use those persistent claims. You'll also need some persistent volumes. Now, cloud providers will differ. Sometimes those are dynamically generated. Sometimes you need to generate them. But yeah, so you can use a persistent volume claim, which will look for a specific disk space, and then it will make that available for you. Once you have that, you can actually use that as part of your container. So you can just mount that volume, and then you have access to that shared file system. So let's go ahead and apply those last files. Kitchen, pastry, everything. Okay, apply -f kitchen fridge, because we also need a fridge. There it is. And now I'll need to apply kitchen chef, and I had a multi with fridge. There you go. All right, so that should take care of everything. So I've changed my chef to be able to access that volume now. So if I go ahead and order drinks, I can order my main course, and I can maybe order dessert, not yet. So it'll take up to a minute for my pastry chef to create that first file in my file system, or that first dessert. There it is. So we've got one. So we've got our creme brulee, and there's no more left. But then that was served by our chef. So what our full architecture looks like now, so we've got our front end that it can communicate to the chef or directly to the bar. The chef can then talk to the fridge, and the pastry chef is producing desserts into that fridge as well. So they don't talk to each other, but they share that same volume. And the chef can also talk to those services that are hidden underneath your Kubernetes cluster. Nobody else can actually talk to them apart from the chef, and then the chef will do the communication back to the front end. So there's a lot of stuff that we've managed to deploy. I don't know if I've been over. I forgot to start my timer just before I started, hopefully. But in the last 45 minutes or so, I guess. So quick recap. I've talked about clusters, which are a set of machines or nodes. I've talked about the master nodes, which is in charge of managing the worker nodes. And the worker nodes are where the pods are hosted. The pods are the basic unit. Basically, a pod is equivalent to a container. So for your mind, you can kind of imagine that, unless you've got some more complex situations. A deployment is the schedule for your pod. So that was our maitre d' who was taking care of scheduling all the different waiters on the floor. This service does the load balancing and accesses to the different pods. So we can't access a pod directly, especially if you have multiple ones running in the deployment, but the service will be that point to dispatch to all of your various pods. We also had ingresses, which was a way to expose those services to the outside world. I've talked about node port, which was another way to expose one of your services to the world. Talked about cron jobs as well, so how to run a job or a container that is not necessarily a server at a given regular interval. Also talked about persistent volume quickly, persistent volume claims. Those you might need to do a little bit of research based on which cloud provider that you're using. But basically, it's just some disk space that you can use and mount as a volume inside your various pods. I saw I've used a few commands as well. So kubectl is the tool to manage your Kubernetes cluster. I did an alias for K, so that's why I was using K. But kubectl apply a file to your cluster, get stuff inside your cluster, get all to identify everything, or you can use with the -L to get a specific label. If you need to debug your pods or anything in your system for that matter, you can use describe, which will give you all the information about a specific object inside of your Kubernetes cluster. kubectl logs will give you the logs of a pod if you need them. You can use kubectl exec as well, kind of in the same way as you could use a Docker exec to log inside of one of your containers. You can just do kubectl exec and open up a bash session into one of your pods. So that can be very useful as well. All right, so that's my whole application. I can now order drinks, order my main course, order a delicious poutine, which you've maybe also learned about today. And we can order our desserts as well. So far, so good. So obviously, this was a bit of an oversimplification. There's a lot more stuff going on into a restaurant. I haven't talked about sommeliers and all the different roles in a kitchen, like a garde-manger and the grillardin and all that stuff. Like there's so many stuff, and kind of in the same way. There's no way I can describe everything about Kubernetes in a single talk. But hopefully what I hope that you've got is just enough information to be able to start Googling stuff and start to explore a little bit, get started with that Minikube and try to deploy applications on your own machine. More resources, the Kubernetes official documentation, great source of documentation, a little bit dry, but it is a good documentation. There's also a great comic about that was published by Google Cloud on what is Kubernetes. And there's Fippy and Friends, which is a great book, which essentially is the illustrated guide to Kubernetes for 5-year-olds. So it kind of explains what Kubernetes is to 5-year-olds. Great book. Really helped me to understand what was going on. Thank you very much for being here. I said I have a typo, DevClub.lv. So thank you. If you need more information, easy URL to /KubeKitchen, or just hit me up on Twitter, Joel__Lord. Thank you.